my name is Daya Beltran. I'm a member of team number 1, and this is our first project. I will be the one in charge of introducing you to our problem, so enjoy. But first, I will be giving you a little introduction about the topic so you can understand better what it means for an object to be moving. When it comes to motion, there are always 3 things that stick to the object in movement. And these 3 things are position, velocity, and acceleration. Position is precisely where the object is located. Speed or velocity means how fast the object is moving. And finally, acceleration is how fast is the object's speed changing.
Point number 1 tells us to write the position equation for the baseball helmet. This one here is very easy because you have your formula and you just have to substitute the values they give you in the problem in it. You have to use minus 32 because we are talking in feet, and this will give you minus 16t plus 90 feet plus 700.
Number 2 of the project says to find the equation of the velocity using derivative definition. So this is how you solve that. To find the velocity equation, we need to use the limit definition. That this is the equation, and we substitute each value in the equation. Therefore, we could be able to eliminate some stuff. So every time we have an x, we put t, that it's actually the same, plus h, and then everything we subtract the actual equation, that is this one, and everything is over h. So we start solving like the polynomial here and the signs here, and we could eliminate some stuff, and then we multiply each value here, and then we eliminate some other stuff, and everything is over h, and then we separate each value and divided everyone over h, and we subtract and we actually divide, and then that we have this equation, we substitute the value of h as 0, and the final limit it's minus 32t plus 90, so that is the velocity position that we can see now that it's the derivative of the first one.
Hey guys, I am Pablo Emilio Morales, part of team number 1, and I will explain to you some questions of the project number 1, which are: first, they ask us to explain the meaning of the obtained velocity, which will be number 3, and then I will explain to you how to calculate the maximum position, which is number 4, and 7 is to calculate after what period of time the model hits the ground. Thank you very much, and I hope you like it. Okay, so for question number 3, which is asking us to explain the meaning of the obtained velocity, it's actually pretty simple. The velocity, which is the quickness of motion or action, is obtained as a result of the equation given by the derivative of the position, as we did in exercise 1 and 2. It explains how fast the object is traveling at a certain amount of time. In exercise number 4, they are asking us to calculate the maximum position. So, when the baseball helmet is thrown upwards, as it reaches the maximum position, its velocity will be 0. Here is 0. So, we just have to substitute in our position equation that we already have, and the equation will be velocity times time is equal to minus 32t plus 90. But because of the maximum height, the time will be 0, so you just have to isolate t, which will give us 32 over 90, which is equal to time, and time will be 0.35. Now we have time, but they are not asking us for the time, they are asking us for the maximum position, and so you have to just substitute in the first formula of the equation of the position, and that will be s times 0.35 is equal to minus 16 times, again 0.35 at square, plus 90 plus 700, and which will give us as 0.35 is equal to 788.04 feet.
Question number 5 asks us to find the value of impact. So this is how we solve it. To find the value of impact, we need to use both equations, the position one and the velocity one. We need to find first the value of t, so we could be able to find the value of impact. As we know, the value of impact position, it's equal 0 because it's on the floor. So we need to solve for t, and therefore we need to use the general formula, that is minus b plus minus the square root of b square minus 4ac over 2a. And we know that a is minus 16, b equals 90, and c equals 700. So we solve it and we find the value of t. So now we're able to substitute this value on our velocity equation. So v 646.87, it's equals minus 2608.88. So now we know that this is our value of impact.
Question number 6 asks us to look for the acceleration of the baseball helmet after 2 seconds. This one's pretty simple too, because you just have to substitute number 2 in the values of velocity, and that will give you your answer.
Finally, number 7, the last part of the project, is asking us to calculate after what period of time the ball hits the ground. So you already had to find the value of impact in number 5. So and we got 646.87 seconds, which is the time that takes the helmet to hit the ground. So for number 7, it's basically the same thing. So our answer would be time is equal to 646.87 seconds. So finally, after doing all these exercises, we came to the conclusion, which is that after this baseball helmet was thrown upwards, we had to find the position, which is s times t is equal to minus 16t squared plus 90t plus 700. Then we had to find the equation of the velocity using the derivative function, which is limit h of h approaching 0 is minus 32t plus 90. But then we had to explain this obtained velocity. Then in number 4, we had to calculate the maximum position, which is s times 0.35 is equal to 788.74 feet. And then number 5, we had to find the value of impact, which is 646.87 seconds. And then we had to find the acceleration after 2 seconds of this helmet, which is v times 3 is equal to minus 6. And finally, we had to find the period of time the bottle took to hit the ground, which is 646.87 seconds. Thanks very much for watching, and I hope you had a great time.